Alright troops, Yoker Uni presents Glasgow Phyiscs. Right, yous lot, let's do some more physics. Question: how high must yous be to get into orbit? Answer: not as high as you think though. You could get about half an inch off the ground if you want to, but in reality there's two big things to heavy stop you. You need to avoid mountains on Earth, so you need to be at least 30,000 feet up. This would avoid the Himalayas, the Alps, and of course the Campsies. Mountains though aren't your big reason you can't get into orbit near the ground. The big problem is air resistance. This is usually ignored in physics problems, so the maths is easier. Leave that stuff to the bottom engineers. Put simply, the faster you move through the air, the greater the air resistance. Depending on the shape, air resistance can be reduced or increased. This is good. This is bad. This is ugly. To stay in orbit at low altitudes, you need to have a lot of energy to overcome air resistance. You need to go higher to move through thinner and thinner air with virtually no air resistance. To heavy show yous, let's have a look at Big Joe Kittinger. In 1960 he went up in a big balloon for 3 hours, and then at 31 kilometres above the ground, the mental nutter jumped out. Cause air is so thin at that height he didn't feel wind or air resistance, and he almost reached the speed of sound. He started slowing down when he hit the thicker atmosphere. But I kept the camera steady, big chap. Never mind, eh? Big Joe Kittinger, what a guy. In actual fact, if you get to 100 kilometres above the Earth, then apart from a molecule or two, or an astronaut's fart, then you've got no atmosphere to slow you down. Right, let's figure out how you use this then. Any jakey can get into space if you've got a big enough amount of ginger bottles and a healthy amount of rocket fuel. It's dead easy to get into space. It's a bugger trying to stay up for one big reason. And for this we need the help of not just any button, but a super button. Big Isaac Newton, Knight of the Realm, created calculus, liked his apple crumbles, and of course, raging mental case. He once stuck a big needle into his eye socket just to have a wee rummage around to see what was back there. Mental. We also heavy farted about with alchemy, trying to make gold out of lead. Alchemy was pure seen as satanic, and anybody doing it were called devil worshippers. Now we call it chemistry, and all links to the dark arts are gone, although there isn't any smoke without fire, that's all I'm saying. Newton didn't discover gravity. He didn't invent gravity, but he did slap some numbers and equations on it to heavy describe how it works. And it's here that we use him to describe satellites in orbits. By the way, big shout out to my main man Johnny Sharko, bit flash learning, for letting us heavy use these diagrams. Cheers, big chap. In my last lecture you saw that a ball fired off a height at a constant horizontal velocity fell down only cause of gravity, but its horizontal speed was constant. If you get a fast enough horizontal speed, then by the time it falls, you heavy have to account for the curvature of the Earth. Cause the Earth curves away, the ball goes further, but it still drops down to the ground. Now we make a cannon pure heavy massive, and it gives the ball enough horizontal speed that by the time it falls to the ground cause of gravity, the Earth is heavy curved around. Here's the big clincher then. There isn't any air resistance 100 kilometres up, so the horizontal speed never changes. The ball will constantly fall because of gravity, but it's going fast enough to never hit the Earth. So going back to the question, how do you get into space and stay up there, then it's simple. You have to get your speed heavy high and then go parallel to the surface of the Earth. Here's a pure Dino photo of the space shuttle. Stupid jakies think it's taken for the space station, but it's not. It's actual heavy taken for the WB-57 chase plane, which keeps the wee eye on things when the shuttle's launched for about 60,000 feet up. This photo shows right away after launch the shuttle's pure firing off at an angle, so that when it's up about 300 kilometres, it's gone fast enough horizontally to stay in orbit. If it wants to meet up with the International Space Station, then it will have to be doing a healthy 17,000 miles an hour horizontally. The plane that me and the troops rallied down to Magaluf only did about 500 miles an hour. It takes a shuttle about 90 minutes to fly around the whole Earth for one orbit. Space is heavy, dino brilliant, and so is physics. Catchy Versace.